Hello, welcome to Ademola, and in today's lesson we are doing redox. Very important topic in A-level chemistry. We're going to cover the whole lot, from oil rig down to disproportionation reactions, and we're going to learn how to really identify a redox reaction and how do we find those oxidation numbers. So we're going to get straight into it. Okay, so en route to understanding oxidation numbers, we got the task number one. Well, redox, we got task number one, oxidation number. So if we just define this first, you wouldn't really get asked to define that, I don't think. But theoretically, it's the charge that the atom would have if it was in an ionic compound. I think that's a more simple way of this kind of waffle that I put there. But it's theoretically what would be the charge of this if it was in an ionic compound. Yeah? And we need to just get these rules down, okay? Uncombined elements, so like oxygen, phosphorus, hydrogen, potassium, could be sodium, aluminium, whatever. If it's just the element, uncombined with anything else, its oxidation number is 0. Yeah? Simple ion is going to be the charge. So chloride ion is -1. Magnesium ion is +2. Fluoride ion is going to be -1. Stuff like that, okay? Remember that. Neutral compound. So again, we've got a compound. So it's carbon dioxide, water. Sodium chloride is the one I got there. Oxidation number overall is going to be 0. So the sum is going to be 0 of that. So maybe in sodium chloride, for example, sodium and chloride will have different oxidation numbers, but whatever it is, they are going to add to 0. Yeah? And then a polyatomic ion, so we're talking sulfate, carbonate, stuff like that, the total sum is going to be equal to the charge. So for example, we've got sulfate there. The total sum of that is going to be -2 because it's a 2- ion. Yeah? Be aware of things like that. Those are your general rules. And then if we get a bit more specific, just remember these, yeah? A group 1 metal is going to be +1. A group 2 metal is going to be +2. Yeah? Typically, when we have ions, yeah, or something that becomes an ion, so like a group 1 metal makes a +1 ion, a group 3 metal makes a +3 ion, a group 7 makes a -1, stuff like that. Typically, don't take that as the rule of thumb, but typically, you would expect the oxidation state to be that. So group 1, group 2, it works really well that it's +1, +2, yeah? Don't hold on to that for the other ones, but just be aware of those. Fluorine is the most reactive element on the periodic table, yeah? Just know that. And if you think about electronegativity, we haven't got to module 3 yet, but electronegativity is kind of this concept of how well a element is able to attract electrons, yeah? So fluorine is going to be very highly electronegative, and that's why it's always going to be -1. No matter what it's in, fluorine should be -1, yeah? Now let's think about hydrogen. Hydrogen typically is +1. As a rule of thumb, it's +1. But if you have a metal hydride, so like for example, a common metal hydride is NaH, yeah, sodium hydride. That's gonna mean that the hydrogen is -1. So just be aware, that's an exception. Hydrogen is -1 in that case. And with oxygen, it's -1 in peroxide. So you guys should know peroxide, H2O2. Oxygen is -1 in that case, yeah? Hydrogen is +1 because the only time it's not +1 is in a metal hydride. In this case, hydrogen is +1, oxygen is -1. And then if you've got F2O, remember we said fluorine is always going to be -1. So in that case, oxygen then becomes +2. But typically, -2. Yeah? Just remember that. Now we've got some examples here. I've already worked these out just in the name of time. But if we look at water here, water is a neutral compound. So you'd expect the total charge to be 0. So again, let's think about the rules. We said oxygen is -2. We said hydrogen is +1. Yeah? So 1 times 2, because we've got 2 hydrogens in water. And then we've also got the -2, so we're going to put that on. That's going to be 0. Yeah? Again, I'm going to show you another example with aluminium sulfate. Yeah? So we've got a neutral compound, total charge should be 0. So aluminium is +3. Sulfur is -2. Again, we're just thinking about what is the charge. So if we break down that, it's an ionic compound, right? So we know the ions that are involved. It's an S2- and an Al3+. So just use that to your advantage. 2 times 3, if we're working aluminium, is going to be +6. 3 times -2 is going to be -6. So they add together to make 0 again. So just remember, if you have an ionic compound, think about the ions that are making it up. And we're going to use that to our advantage here when we're talking about ammonium sulfate. Yeah? Total charge is 0 because it's neutral. So let's split it up into its ions. It's got an NH4+, and it's got an SO4 2-. So we split it into the ions, and now we're thinking. We know hydrogen is always going to be +1, unless it's in a metal hydride. Remember your exception. Now, that's 4 hydrogens there. So 4 times 1 got +4. But we have to think, if this is a +3 it's a +1 ion, right? So that means, again, let's think about it. We know that that means that the sum of the oxidation states should be +1 if we're just focusing on that ammonium ion. So 4 take 3 is going to be 1. We're going to have that the nitrogen is -3, its oxidation state. Cool. Let's move on. We've got sulfate ion there as well. Oxygen, we said, is -2, and it's in a peroxide, or it's with fluorine. Yeah. So let's do -2. There's 4 lots of them. So -2 times 4, -8. We need to make that up to -2 because the charge of the ion is -2. So to make that back to -2, we need to add on 6. So the sulfur is going to be 6. So you put it all together. The nitrogen is -3. The hydrogen is 1. Sulfur is +6. And oxygen is -2. I really hope that made sense. Any questions about it? Ask in the comments. Rewind the video. Just try and digest it. Yeah, that's the kind of process that we need to do when we're talking about oxidation numbers. And just kind of to wrap up with the naming, let's talk about oxidation numbers. So let's talk about naming it. Yeah, we are typically going to use Roman numerals. So just remember your common ones. Yeah, that's equal to 1. If we do this, that's 2. We'll just keep going. 3, 4, 5, 6. 7 should really be the highest that we're getting, yeah? Just remember those Roman numerals, yeah? So let's go into an example why this naming thing is important. I've got iron oxide, yeah? So I've just been told it's iron oxide. I need to figure out if it's FeO or Fe2O3. Just note both of these, yeah, we can accept are going to be called iron oxide. But how do we differentiate it? Well, we know oxygen is always -2, yeah? That's what we've been told. And we know these are both compounds. So they are all going to be 0 because they're not a charged compound. So we need to do the -2 plus whatever this is going to be 0. Let's rearrange x equals 2. So in this case, Fe must be 2. Yeah? And we've got here Fe2O3. Well, we know -2 times it by 3, we get -6. Yeah? So -6 plus, remember there's 2 here. So plus 2 lots of x is going to be equal to 0. Well, move it across, 2x is equal to 6, x equals 3. So Fe here is 3. So we can see here, we've got 2 different sets of iron. Yeah? Got the 2 and we've got the 3. So now we can call that FeO is iron 2 oxide. Fe2O3 is iron 3 oxide. Just be aware of that. These are different compounds, but they do have the same name as iron oxide. We just need to know what's the oxidation state of iron. Now, the reason why we have to talk about this is because when we talk about transition metals, they can form different ions. Again, that's properties of transition metals. You'll learn more about that in topic 5, I believe, when you focus on transition metals. So, very, very important to know, because there's going to have variable oxidation states, this is why we need to worry about oxidation numbers. So we know which compound we're dealing with. And also chlorates as well. So, for example, one chlorate would be NaClO. We've also got like NaClO3. Stuff like that. The chlorine there is going to have a different oxidation state. So we need to know which one we're working with, which is why we do these oxidation numbers. Now, another thing that's important about oxidation numbers, maybe not within specific molecules, but we need to consider redox reactions. And that's what we're going to do in the next slide. Okay, so I know this video is taking longer than usual, but I think it's important to be systematic about this. So, redox reactions. Now, a redox reaction, in simple terms, reaction in which oxidation and reduction occurs at the same time. And literally, you get your marking exams to say that. So the main thing we need to do is OIL here. It's an acronym. That stands for oxidation is loss of electrons, and reduction is gain of electrons. I didn't finish writing off electrons there, but you get what I mean. Yeah? OIL. Oxidation is loss of electrons, reduction is gain of electrons. Just keep and hold to that. That will help you with every single redox reaction that we do. So let's see an example here. You've got magnesium plus hydrochloric acid goes to magnesium chloride plus hydrogen. Think about the rules of your own oxidation numbers, and we're going to just apply it here. So if we focus on the left-hand side, yeah, magnesium is 0. The hydrogen is +1 and the chlorine is -1. And we've just got that from the ionic charges, yeah? Now if you look at the right-hand side, again, think about the ionic charges, think about the element that's on its own, yeah? Magnesium now is +2, hydrogen is 0, chlorine is -1. Now you need to identify the changes, yeah? You can see magnesium went from 0 to +2. You can see here that hydrogen went from +1 to 0. Chlorine stayed the same. Yeah? So you can see that's a redox reaction because oxidation and reduction occurs at the same time. So magnesium has lost electrons because it's gone from 0 to +2. So a positive change in oxidation number means that you're losing electrons, yeah? But lost electrons oxidized, and the hydrogen has gone from +1 to 0. oxidation number has gone down, it's been reduced because it gained an electron. Yeah? That's the mindset that we need to get into when we're answering these questions. Now, just another term. Reducing agent and oxidizing agent. A reducing agent donates electrons. It is reducing the other thing involved. So in turn, it's oxidized. The oxidizing agent accepts electrons. It's reduced because it accepts electrons. It is taking and gaining electrons. Yeah? So in this question, magnesium was reducing agent. Hydrogen was the oxidizing agent. Now, we're going to go through another example. Yeah? Let's get this reaction spaced out really nicely. Chlorine plus sodium hydroxide goes to sodium chloride plus sodium chlorate plus water. Again, think about the oxidation states, yeah? I feel like I've given away the answer if you were eagle-eyed enough. But look here, yeah? We said oxygen is always -2. We said hydrogen is always +1. So to balance that out, sodium must be +1. Yeah? Cool. Here, again, we're thinking about the charge of the ions. +1, -1. And you can see here what else is happening. So, well, oxygen is -2. We know that's sodium, because the ion here is the chlorate ion, yeah? That's the ion. So, sodium must be +1, it's normal ionic state. The chlorine then, to balance that out, has to be +1 as well. Yeah? I'll just breathe on it for a second, think about it, yeah? If the chlorate ion is going to be minus, and we know the oxygen is -2, we only add on 1 so that you still have the minus charge in the ion. Yeah, and then the sodium being +1 balances out the whole compound. Cool. And in water, well, again, we've done this before. This is +1, this is -2. So you can see here, if you look at this reaction, chlorine is oxidized. So we think about what chlorine is initially, 0. You can see here that it's become -1 here, and we can see here that it's become, that's sodium. You can see here that it's become +1 here. So you can see chlorine is oxidized and reduced at the same time. And this is what I need to bring in. That is called a disproportionation reaction. That's the last one we need to know. A disproportionation reaction is a reaction in which the same element is oxidized and reduced. Yeah? So oxidized and reduced at the same time. Disproportionation. It's another type of redox reaction. So just be aware of that. I hope working through that has shown you how do we go about a question like that. Okay, I felt like I've done a lot of talking, so it's your turn now. Pause the video, have a go at these questions. So we've got the first one here. I'll leave it on there for a few seconds. And we've also got this one here. So we've got 2 questions for you to try. Have a go. Pause the video so that you can see the questions. I'll zoom out a bit more, but it might be less clear. Have a go, and then we'll come back to it. So we've had to break it down. Yeah? Just think about it like this. We know that oxygen is -2. Yeah, oxygen is almost always going to be -2. Times it by 2, we've got -4. So to balance that out, that manganese has to be +4. Yeah? Then let's think final oxidation state. Look at manganese, 2+ ion, yeah? Cool. Happy days. Iodide there. On this side, it's -1 ion. We're chilling. Then let's look on this side. It's by itself, so it's 0. I hope that makes sense. Yeah? Think about the rules that we did at the start of the lesson. Now, the half equation for the conversion of manganese oxide to manganese ion is shown there. Yeah? In terms of electrons, why is the manganese said to be reduced? Well, gained electrons. Remember oil rig, reduction is gain. Yeah? You can see here the +2 minus, it gained electrons. We're happy with that. Cool. If you look on this side, again, let's think about it. So, if we just get to the answer, it's a bit of cheating, but we said that oxygen is oxidized and nitrogen is reduced. Yeah? So let's just focus on those 2 for now. Okay. Let's look at this. So, we needed to get the oxidation states of everything here. Well, I can already see that compound is Mg2+ mixed with an NO3-, yeah? That's what we already know. So we know that the magnesium here is 2+. We know that, let's have a look at this one. So we know oxygen is going to be -2. -2 times 3 is equal to -6. And remember, it's a -1 ion, so we just need to add the 5 and we'll get -1. So nitrogen here is +5. Cool. Let's look on this side. Oxygen is -2 here. -2 times 2 is equal to -4. So the nitrogen here must be +4. We can see a change. Let's see, again, oxygen here. Oh, oxygen is just going to be 0 here. Yeah? I don't know what's just happened now, but oxygen is going to be just 0 there. Yeah? Because it's by itself. So you can see there that oxygen got oxidized because it went from -2 to 0. And you can see that nitrogen got reduced because it went from +5 to +5 to +4. Yeah, so you can see the workings out there. I know that the writing went a bit off there, but I hope you guys understand from not working. Okay, thank you for bearing with me. I realize I've talked a lot in this lesson, but it's just that redox can be a bit difficult to get your head around, so it's important that we did it in detail. Now, unfortunately, for such a difficult topic, I don't have much A-star tips because I feel like when you know the foundations of this, hopefully you should be able to get it. So, know your oxidation states, yeah? Know what's common. So, like, for example, oxygen is almost always going to be -2. That's a banker if you come to the exam. If they want to be really mean and they put in a peroxide or they put in F2O, yeah, just be aware of it. Know the trends as well. It will just help you out if you know that a group 1 element is most likely going to be +1. A group 2 element is going to be most likely +2. Look at the periodic table to help you out. Also, when you get to transition elements, if you know the ions that the transition element can form, typically that would be its oxidation states or a possible oxidation state as well. So again, that. And then just practice, guys. Practice makes perfect, genuinely. Keep practicing this. It will land eventually. Now, don't forget about the exceptions, yeah? The hydroxides, the F2O, the metal hydrides, yeah? Just remember the exceptions because if that comes in the exam, you've noticed it, you're gaining marks. Cool? And Roman numerals, guys, literally, I'd say you only really need to go up to 7 anyways. So I don't think it's that hard to learn. Just know your Roman numerals 1 through 10 to be safe. And I think you're going to be completely fine when it comes to A-level chemistry, yeah? I'd say if you don't know the Roman numerals, just put down the number, but you might not get the mark for that. So literally, learning your Roman numerals from 1 to 10 isn't that difficult. Just make sure that you do it, yeah? But for this lesson, that is a wrap. I know I've talked a lot. I'm tired of hearing my own voice too. But literally, any questions, just comment below. I'll do my best to answer as quickly as possible. Like the video, subscribe to the channel, por favor. We've got the TikTok and the Instagram, both at Ademola. Give them a like as well. And I will catch you in the next one. Bye for now.